Hello. Is someone there?
Hello.
Hi, good morning. I was just ensuring that my sound.
Yes. Good morning, sir. Yes, we are just waiting for participants. They are just joining, so we'll just start within 5 or 10 minutes.
No problem at all. Thank you.
It's okay.
Hello, Moses.
Hello, good morning.
Good morning. How are you?
I'm very well. Madhavi, is that?
Yeah, Madhavi.
Yes. How are you?
Thanks for coming here.
Thank you very much. Thank you for the invitation, and it's my privilege.
Yeah, you're most welcome. We need people like you.
Thank you.
I think we have another panel session at 1 o'clock also.
Yes, I was told yesterday when I had this conversation with
Ashwini
Dr.
Kumar.
Prasad.
Ashwini
Yes,
Kumar.
Ashwini. Yes. Yeah, Ashwini Kumar. Yeah. Excuse me.
Good morning, sir. Moses, sir, good morning.
Good morning, Dr. Prasad. Sorry, I didn't realize that I went on mute for a while. Sorry.
Okay, sir. Sir, exact 11:30 will start, sir.
Yeah, absolutely fine.
Okay, sir. Thank you, sir. Thank you.
Thank you. Thanks.
హలో అమ్మ నేను మీటింగ్ లో ఉన్నాను, తర్వాత మాట్లాడండి.
Okay, good morning to all. Welcome to last day session on FDP on academic research in engineering for industry and patents. Even our speaker available, Moses sir. Madam Smita Sri, madam, please introduce our speaker. We'll start the session.
Okay, sir. A very good morning to everyone. I am Smita Sri Mahapatra, working as an assistant professor in the Department of EC at MVSO Engineering College. Now I am here to welcome Mr. Moses Gumadi, a special guest from UK. Mr. Moses Gumadi, who has done his bachelor's in mechanical engineering from Nagarjuna University. He brings over 24 years of experience to his role as an operational excellence and business transformation professional. His expertise includes shaping, deploying, and leading transformational programs including operational excellence, Lean Six Sigma, operational strategy, and the list goes unending. He has also worked with some prestigious clients of various sectors like manufacturing, retail banking, IT services, etc. Presently, he is working as an independent consultant at UX Consulting, West Midlands, United Kingdom. And today he will be sharing with us his expert opinion on requirements of engineering research for industry. With that, I ask that you give your full attention to Mr. Moses and help me in welcoming him. Welcome you, sir.
Thank you very much. Appreciate it. Thank you. Thanks a lot. Dr. Prasad, is it like I have to start, or like are we waiting for something else?
Sir, you can start, sir, please.
Okay, right. I will just, I think, start sharing the screen. Maybe, let me check if I can do that. Okay, so I just, share my entire screen. Good morning to everyone. Thank you very much for this opportunity that your college has given me to come over and share a little of my experience in the past of how I have and my teams have carried out engineering research. And basically, obviously I will be talking about the requirements of engineering research in connection with industry applications, as I think they have requested me. So the title is pretty much requirements of engineering research for industry. And yes, so just a little about myself. Obviously, they have given a background. I am not working as an engineering professional fully at the moment, although there is significant contribution as an engineering professional in the past. And I'm hands-on on other things, including, of course, I've moved on to the computational side, and I'm in touch with the manufacturing side as well, as I consult with manufacturing companies. But this is a bit of my brief, and I don't want to say much about myself because already somebody has introduced me. So I'm grateful. This is the agenda for today, basically. So I've got 3, 4, 5 topics that I will cover, at the end of which I will try to summarize the requirements for engineering research. But obviously, as we go through, we can find a lot of requirements coming in the discussions. So first of all, I'll talk about briefly research opportunity in the society and the industry. And secondly, more importantly, how do businesses create wealth, or how do they create value, and what do they really care for? And this understanding is what really helped me in both in the past. In fact, I should say, to come up the ladder in GE, in General Electric, This is one thing that helped me, that I gained, as opposed to my colleagues, which helped me to go faster in the career where I have done. Although we all had the same engineering capability, so I think that is a very good thing. I have not tried to complicate that, and I'll try to briefly simplify it for you folks. So it's good to look at it. Thirdly, I will try to show you some examples. There are a lot of examples. Some of them, have been patented. I will not speak exactly what has been patented, but obviously because of IP reasons, I will show some pictures which I try to obtain some desensitized pictures, obviously from my past experience. I will also explain how we can not only work in research not only on the products, creating new products or anything like that, but in fact, there is opportunity across the value chain. Most of the times I've noticed that attention is not paid there because people do not realize there are opportunities. And so I'm going to show you the areas of opportunities and how to look at things to identify research opportunities and to shape your research projects in line with how business would like to have them and how they could be benefited. Okay, so that's pretty much what I want to cover. So let's start with this 4 blocker. I do not know if any of you have been familiar with the 4 blockers as such. Sorry. Can you see my screen in full just to ensure that you're all able to see my screen?
Yes, sir.
Okay, great. Okay. So just to start our thinking in terms of this 4 blocker. So I have on this horizontal axis societal value. Now I'm mentioning this particularly because obviously people talked about wealth creation and generating value, which is of course the purpose of doing research. We don't do any research for just the sake of it, or you could do that in probably government-funded research organizations to some extent, but definitely not commercial research. And so societal value on the horizontal and shareholder value on the vertical. Not only companies obviously not only seek to seek to gain shareholder value, but also customer value, without which they cannot gain the shareholder value. Therefore, we'll talk about that as well. Let's talk about 2 parties now. One is generic societal value, and the other is the value that the company owners or the shareholders derive. And the products and the innovation depends on where do we fall on this one. And the requirements for both society and the industry they're slightly different. So I'm sure you know that there's no rocket science. I'll give you an example. I will give you a couple of extreme examples so that you can make a sense out of it. Okay, so I have here the example of a luxury yacht. This is the picture. This is the latest project that is going on at the moment in University of Southampton. It's an engineering project. It's a live project, actually. I have picked up from their website. And they are currently doing an active research on the sound and vibration control, noise and NVH project on a luxury yacht. They're very expensive. Obviously, it is not a common commodity that is sold for everybody across in the market. The areas of research obviously involve acoustics, mechatronics, signal processing, digital signal processing and control, and a lot of advanced stuff going on. And obviously the technology that they develop and use and make money from there, the universities obviously are funded for this because they've got that project. And probably some of it is actually multi-year or something like that. They get funded the PhDs, and I'm sure there will be some patents as well out of this work. Now, The technologies can be transferred. It is not that you can't transfer the technologies. For example, that the phone technology, the smartphone technology, some of the technologies we enjoy today of email and this video conference, etc., they existed long ago in the U.S. military and the Department of Space, etc., and they have been transferred later on after a very long time. And so this could be transferred as well. It will take time. That's the point. This is an extreme example of something which has a high shareholder value, right? It's on the totally onto the left of the societal value. That's the point we're trying to make. Whereas I'll give you another example. I'm sure you're familiar with this one, Gal Mobile or Gal Mobile, which Prime Minister Mr. Modi, along with Netanyahu in Israel, have sat on it and have gone around it. And this is the picture of this. It's a water purification vehicle. Now, this is definitely a very high-tech research-oriented project, and they have not only done research and patented a lot of things, but also they have produced and made it available to the public, obviously with significant government funding, also some private investment as well in this area. And you can see that the amount of societal value that it adds is tremendous. If you see some of the use cases, and I think this is one of the things we should probably be talking about, the word use cases. So when you create a product like this or something that could be useful, what are the use cases, right? So the lack of fresh, clean water in the first 72 hours is a main challenge following many large-scale natural disasters. So if there is an earthquake or floods, for example, there were floods in Kerala. I think at the moment as we speak, there is a cyclone, I think, hitting the west coast of India. And there was one on the east coast, I think, in the past. And when people are affected, you want fresh water. You have only muddy, bracky, turbid water sources. You just connect some turbid, muddy water sources, and this thing will output, high quality WHO standard water, standard drinkable potable water that one can drink, and stores up to 10,000 liters depending on the tank size, and only costs 70 lakh rupees apparently, which is, I think, one of the greatest examples of wonderful research done and societal value produced highly. But obviously, shareholder value at this stage will be minimal, but definitely it can be moved. So what the point I want to illustrate to you really at this moment before I move on, I don't want to spend a lot of time here, is that in research, there is something known as a value frontier as far as shareholder and societal value is concerned. Meaning, so this yellow line that you see on the screen has a limitation. You cannot go to that top upper right box in both ways. It's not very easy. If you provide more of a societal value, it is very difficult to generate shareholder value and vice versa. And therefore, depending on the sort of project that you have embarked or taken upon, you must be obviously careful about, generating your, funding. Who do you go to? And what sort of language do you use while you are interacting with your from the people who fund. Sometimes you prepare a presentation or a pitch, so you need to talk to them in different languages, obviously, depending on, I think that's one of the keys. So technology can then help us, modern technologies can help us to move this curve upwards, which is obviously possible. I just wanted you to introduce to this way of thinking in terms of societal value and shareholder value and different ways of messaging, etc., just as an introduction before we move on. Now, I don't want to spend too much of time on the societal value. There are significant amount of research that can be done, and you can get funding. You probably can get patents. Yesterday, I was told by Professor Ashwini Kumar, this is primarily about the patents, and I understand that I think the last two sessions have been about the patents. But in general, if we just widen it up a little bit, and talk about generating value, generating revenue, even for the college or for people. Patents is one of the way in which you could do that. You could obviously, you can charge consultancy. You can sell technology that you develop, which is patent again. So whether patentable or not, some technology that is developed could always be sold in different ways, or you could sell services, sell consulting, etc., both to the government as well as to the companies. Now, I only have here some of the examples, and sometimes I think about these things, but you can't do everything. you can't do everything. But some of the examples that I can think of, and I encourage you as engineers and as teachers, I'm sure all of you are teachers, as teachers of engineers, please do think very high. Tap water for everyone. Rapid. Imagine, just imagine some bit more developed. I think we are all developed in India. Our cities and our people are, obviously there is a large section of the society which is obviously not developed, and we understand and we know that. There are countries where they may not be like US and the UK or Europe, but still there is a bit of an improvement in terms of general living standards of people. And so I think just by comparison, we can get tremendous amount of ideas, and if we keep an outcome as a goal, I think we can generate a lot of projects. And I don't want to spend some time. So my real focus would be today for industry. Okay, for industry. Dr. Prasad, how do you handle the questions and answers? So do you allow somebody to stop me? I mean, I'm okay if somebody stops me and asks me a question in between.
Okay, sir. You can. Even in the middle also, you can make an interactive session, sir.
Please do. That's what I don't want to make it a monologue and just I'm talking and people are listening. So and if I'm going faster, please do stop because yes, it might be sometimes I might go stop faster.
I request participants, if you have any doubts, just you can.
Doubts or questions, please, or challenge. You could challenge as well. So let's make it as a discussion, because obviously ideas emerge through collective thinking much more than I think an individual's perspective, which obviously could be valuable, but still. All right, so I'll start with this slide. So what I did really in the last slide is just try to show you a few things, right, in terms of the societal value. I'm not still talking about the requirements. One of the key requirements is obviously generating value and highly focused effort. So unless the research that is produced is tangible, eventually can be converted into practical use that can be used and benefited by the society or by the industry, and if money could be generated, if it is for the industry, etc., there is no ultimate use of such a research. That's my take. I mean, you could do a lot of other researches. You could do academic research in physics, for example. That's a different thing. We're talking about engineering research, and therefore that is a key. And which is why I think thinking about problems is one of the good way of coming up with projects. Sometimes solutions could be not that difficult if we really understand the problem. I think half of the problem could be solved by really understanding the problem and articulating it. And that's the reason why I have just suggested some of these. But I don't want to lose focus on the theme of this session about the requirements. And I have a lot of information material on the industry. So I will move on unless if anybody has something to ask here. Or in case if you have any questions for asking me to come back to this slide, I will do so. Okay, so coming to the industry, which I can very confidently talk about, obviously, I will start with a ladder. Okay, I'm starting with a bottom up. When people talk about research, they think only about creating altogether new, fresh, new products or ideas using the latest technology. Now, you could do that. You should do that. And there is no doubt about that. But I'm trying to suggest here that there is huge amount of opportunity that exists even in existing products. Existing products exist. You can bring in new, slightly modified, improved new products. So improving existing products a significant opportunity, and it can be research oriented. We have done research on this, and some of the products are, some of them are old as well, like a 20-year-old, 30-year-old, etc. And companies keep on going, make some minor modifications, but you could actually upgrade the technology and massively reduce the size, reduce the cost, improve its performance, etc. We'll talk about those things. So at the bottom level really is improving the existing products. And secondly, new product introduction. Every company brings in new products almost on a yearly basis. They have a product development department or new product introduction departments, and most of the time they do use the same technology. There is nothing rocket science. They use the same technology, but a little bit more optimized, and they get better performances. They get a better size and better shape, better materials, perhaps better producibility and cost, and a little bit refinement, and it looks different, and they could sell the product slightly cheaper, etc. And again, we're not only comparing with the likes of Apple. See, remember, most of the products that you see, engineering products in the market, Apple, these sort of technology companies are obviously exceptions. They're highly, obviously, exceptions. So there are everyday products used in commercial context, industrial context, home context, which are engineering products. So they use the same technology and do optimizations. A third level of innovation, new products could be, I suggest, new systems. Think about systems. When you say it is not a product alone, it could be a product, but it is more of a system using existing components and technologies. But this system then is totally new and delivers some new use case or delivers some new benefit, solves a problem that hasn't been solved. For example, the GAL mobile, we talked about, the water purification portable mobile unit, right? I don't think that the root technology within that, including the reverse osmosis and other processes they use, and the mechanical and the electronic and the control systems and the vehicle technology they have used, there is nothing new. There's nothing new. All they have done is they have engineered a system with existing components and technologies, and that gives you a new use case and solves an outstanding problem in the society, or helps a manufacturer or an industry to introduce a product into the market and both generate shareholder revenue as well as societal value. New products using emerging technologies. Obviously, there are new products. We have drones, and we have machine learning, we have artificial intelligence, imaging, and we have power systems related digital signal processing used. There are a lot of new, DSP is an old technology, but there are a lot of new technologies that are there, and people are indeed bringing new products. There is no doubt about that. But all I'm saying is, if you count the number of products, if you calculate the value of revenue, or at least the number of units sold and their usability, bulk of it sits in the bottom. So do not, this is like an iceberg. What you see in the iceberg is on the top. The only, a bit of it is floating on the top of the ocean, but bulk of it is a hidden opportunity sitting under the ocean. It is exactly like that. If I color, for example, the first two or first three in a different color, that would be the iceberg underneath the surface of the water. People only talk about the new technologies or emerging technologies. Obviously, the top one is to create and build new technologies. Universities are indeed, of course, I'm sure they may be doing like that in India in some of the IITs. I'm not sure about your college. Some people do build totally new technologies, and that is not limited only to the industry. In fact, they do come from universities. So, I mean, if you have confidence or if you want to really stretch, I think that is something that you can aim at as well. But just remember, there is a huge opportunity for industry. There is a sort of a ladder. Bulk of the opportunity exists down below, and you can generate significant value. You can get money from clients or from the industry because you are contributing to their revenues. And I will show you how to do that. And that's the point that I will be discussing here. How do businesses create wealth? Before I progress, just wanted to check if you have had any questions or anything to ask so far. Anyone? Dr. Prasad, just making sure I'm audible, okay, and just in case if there is any help. Yes, go ahead.
Good morning, sir. This is Gauri.
Morning, Gauri.
Faculty from Chapel of Technology, sir. Sir, I have a doubt. Sir, we are speaking about industry.
Yes.
But I could say that we have a lot of gap between institute and industry. We are speaking a lot about it.
Correct.
And when we take up new technologies nowadays, and we feel that maybe because of the gap between the industry and institute, I may say, I think CSE and IT people are finding more opportunities for programming and bringing out new things than other people, like in terms of electrical department, still are hesitating to take up or to feel that I can do something for this and take up something of the industry so that I can work on that, because they lack the software knowledge, I think. This is only my opinion. So in that case, it is not possible to incorporate everything in the silver spot industry. So in that case, if we have to collaborate with the industry for the new things, because this is not only for or something, even students are also involved in that, I believe in that. In that case, how to bridge the gap, to bring the students to research which is industry oriented. So
Absolutely. I fully understand your viewpoint, and I do believe that is the case. And I do know the reasons as well why sometimes there is a gap between, why is there, no, it's not sometimes, there is a gap between the institute and the industry, the engineering colleges and the industry, because I have worked with engineering colleges in the past during my engineering career, and also I have interviewed, I've gone campus recruiting, and I've interviewed people, etc., and recruited as well. So, and I've worked with the professors, and so I do understand, and I will give you precisely the reasons why I think where the gap is. So I'll try to address that question, Gauri. So just come back a little bit later on as we progress. If you don't mind on that, I do address some of those points. Okay. Yeah. Right. Okay. So let's. Yeah, thank you. Thanks. Let's pay attention to this particular slide. Okay, this is very important. How people do know the profit and loss. Everybody, and there's nothing, no rocket science about it. You know, when you sell a product, right, it costs you, say, 1,000 rupees and to produce, and you sell it for 2,500, and 500 is your profit. So people talk about, okay, so how do we increase the profit? By making material changes, performance changes, blah, 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 whatever. That's what people think. Businesses do think that, but it's a much more than that. It's slightly nuanced than that. And there is a time element in it. Okay, and the scope is not only limited to the product, the scope is a bit more across, it stretches across the supply chain, And this is where I want you to pay attention a little bit and understand kind of what I'm saying. And then I think we can address that particular question. So we all know our personal investment. We put in money in the bank and fixed deposits, or maybe some of us, invest in the stocks, etc. People, so the red arrows are essentially investments. They are the money going out of the organization or out of the house or out of our pockets. Those green ones are money coming in later. Okay. Now, this is how businesses create wealth, period. That is how they do it. Now, you can say, well, they do research, they sell products, and they are very passionate about the products. If you ask any company, what do you do? They don't talk about, oh, we make money. They say, well, no, we provide services and this and that to the companies, and that is all correct. However, as a consultant who has helped a lot of companies, you see, you cannot produce a product, you cannot sell a product without, getting a return. Obviously, we all understand that. But the critical thing that I wanted to show you is here is the time element. What is known as a return? This is the key thing that they are after. Return on invested capital, meaning they spend the money. All of the money that is spent upfront, money spent upfront, right, has to produce a return later. And I'm sure you know the time value of money. 1,000 rupees today will only be valuable 900 rupees maybe 2 years later or 1 year later, and vice versa. If I put 1,000 rupees now in the bank, it will become more, etc. The point simply is, when a business exists, why should I not simply invest my money, put it in the bank or the stock market? Why should I invest it in equipment? Why should I hire the people? And why should I undertake all the headache and create an industry? Is obviously, the question, whoever the investors are. Some people do invest a lot of money in technologies. And the reason is very simple. Every business and every project in business. I'm coming from GE experience, General Electric, which is known to use this sort of thinking. So every project undergoes a certain criteria in the beginning. What is one of the things is a business case. Why are we doing this? What benefit does it get? How does it solve customer problems? How does it generate any difference to the business? Sometimes we do, spend money to solve customer problems, although it may not give money immediately, with a view that it will give money in the future, because you're keeping the customers in the shop so that they will buy your new products because they gain the confidence, etc. So any way you cut it, they are looking for future returns that will pay more. So there is a time value. And so what they really want to do then is not only about the rate, it's not only about the profit and loss, but it indeed early returns or the time element is the key. And why am I emphasizing time element being the key is because this time element is not only present in the product development lifecycle, it is present in the manufacturing, it is present in the distribution, in the end-to-end cycle, it is present. See, for example, now let's take this box as a business enterprise, okay? This is a company. Let's say this is a company. You conduct R&D. R&D obviously is slightly different from the product design. Product design is highly focused and you create a tangible product. You can do a lot of, back and forth on that. There is a particular process for it. And then obviously once the product is designed and drawings are produced, it is tested, it is prototyped and tested, and it can be manufactured. And then you start manufacturing. It takes time to manufacture. So you can't produce and then you distribute. You put it in the shelves of the stores or wherever the product is, and you get paid. Before you get paid, they spend the money for plant and equipment. They spend the money on the raw materials and other goods like oil and blah blah blah, electricity, everything. A lot of money is spent. They spend money on operating costs, which are for human resources, a lot of other things, right? And most of it is working. Some of it is, I don't say most of it, as a substantial chunk of it is called working capital. And I don't want I don't want to explain for these financial terms, but it's simply that working capital can be recovered at the end of the cycle. You put in it's like a restaurant, like, before you produce something, you need all the goods. So you need some money to produce it. It is not the capital equipment, but the flour, the rice, and the chicken, and all that stuff. And once you sell it, you get back the money. That's working capital. They spend a lot of money throughout this to obviously sell more volume. They're focused on volume. They're focused on growth. How many more customers can I sell? How many new markets can I sell, etc. And then obviously they are interested in the revenue, which is the turnover, which can be through volume and price. Price multiplied by volume will give you the revenue. Average price multiplied by volume will give you the revenue. So this is it. And in all this, the point I'm trying to make is there is a value creation cycle, and that is the time element. And so there is an upfront investment, and there is a return later on. There is a time element, and obviously they want to reduce all these things that we're showing on the red arrow, right? Because you have to bring them down, and you have to bring this up. But this is exactly what the business wants to do. And if your product is aligned to this, and I will talk about how to get your research topic aligned to their thinking. It is all about communication. How do you pitch, or how do you present? When you go for funding, when you go to the talk, you need to talk in their language. So we most of the times we talk in terms of sometimes there is a PR element as well. Even the businesses are interested in incorporating good technologies for PR purposes, not necessarily for value purpose. For example, in the past, you might have heard in the past, 20 years past to 25, when we were young, people used to call fuzzy logic, washing machines and fuzzy logic. No one knows what fuzzy logic is. It's just a buzzword, and people buy it. And if it's the same thing today, artificial intelligence. Most of the products that are coming up nowadays, we have artificial intelligence. It is not really artificial intelligence. Hardly any machine learning in it. It's a bit of a small algorithm, but people calling artificial intelligence. No one really knows what's inside, and so people use buzzwords. And so it is indeed good to use some of these new technologies, and people do buy that. However, what they really are looking for is this. Again, I go back to, so there is an investment, and there is a return, and there's a time. Earlier the return and bigger the return, the better. Not only that, lesser the investment, the better. Shorter the time, the better. This is the reality on the ground in any industry. This is the reality on the ground. Now, forget about this. If anyone is interested later on, you can contact me. I'm happy to help you. But I consult with something like this. I don't want to explain things that are not necessary for you, but perhaps in the businesses, to improve this return on invested capital, you can actually mathematically look at the structural way they have configured their business, and you can improve it. They're mathematical relationships. You could actually do it. So it is possible to appeal to them. When you, again, I don't want you to show this map as well. I think probably I. So let me come to this product design/redesign. Now that we have understood what businesses want in terms of the financial returns, and remember, no financial return can be achieved by businesses without paying attention to the customer. So people talk about the voice of the customer. Research is carried out based on the voice of the customer, not only performance, not only cost, not only profit, but indeed by product redesign or by innovation. That includes patents. My team has patented ideas. They may not be great ideas, but there are a lot of them patented. Company has spent money to patent them. And they were produced in the process of improving the product performance, magnetic. And I don't want to go into the detail of it because of the IP involved. But so this is how they think. And what is a benefit? Again, you immediately should, what is a benefit? Benefit is a simplification. What does simplification mean? You reduce the number of parts. Reducing the number of parts itself is a huge help, because cost saving is one thing. Even if there is no cost saving, reducing the number of parts means the assembly time and the errors that can happen during the assembly, or perhaps failure opportunities. The opportunity to fail. If there are three parts assembled, three components are there, you have three opportunities to fail, as opposed to one unit. The opportunity, well, not necessarily always, but you get the point. So it is a simplification. Simplification can help massively. Second, see Peltier effect for cooling. So I will talk about that as well in the next. I'll show you that particularly. Peltier effect, temperature rise, why that is beneficial. People are talking. Number three, if you see, eliminate mechanism with simple systems. They use a certain mechanism to have a latch engagement, meaning there are two parts like this. If you can look at my face, maybe. I don't know if I'm visible, but there is a latch. I probably have a picture, I think, later on, so I'll show that. So eliminate a mechanism. So there'll be a latch like this, an overlap like this, which is a critical part in the circuit breakers, and sometimes it fails because the latch is variable. Variable in the sense, it is not variable as it is engineered. It becomes variable in the real product. One product will have so much, but another product will have only too little, because of the way it is assembled. Because of the way it is assembled, there will be variations in product to product, even though it is the same product, and which is why sometimes it trips when it is not necessary to trip, etc. So they want to replace it. Works, then you can. I want to briefly want you to have a look at this one. So there are 4 stages I'm showing here: research and development, initial research and development. Once we figure out there is a viable product that can be designed. When we talk about design, we're talking about the actual design. So we physically choose the materials, we size it, and start producing drawings, and maybe a little bit of innovation is there, but still it is more of a tangible design rather than pure research and analysis phase. There will be analysis in new product introduction as well. Okay, so research and development, new products, new functionality, usability, better performance, all of these are there sitting in that area. But even in the new product introduction or product design or product redesign, development time, development cost. For example, if you come up with some method of cutting down the thermal analysis in some sort of problems by half, you write a macro or you write something that will analyze multiple shapes by reading some parameters, and then you automate it, you give a run, and then it will do in the night and come back and produce results, something like that. This is a part of research. You cut down the time of development massively or significantly. Is one good thing. Another thing is, people spend quite an amount of money in testing. They buy products, they physically build prototypes and test them. There is a testing cost involved. They have to pay to the testing agent manufacturing, and you could avoid them by and you can improve machine reliability or the manufacturing machine reliability. Some industries have this problem. They may not have problem with the product. They have technology issues where research can help to improve their reliability of production. Its accessibility improves, and that you can improve the design and achieve that. Ease of deployment. I'm sorry, the maintenance free I've got twice there, but so maybe I should show you the contactor. You can still see my screen, so I think I should have, yeah. So this is something like this. Okay, so a contactor is like this, right? Okay, so that's, I think I've already talked about the innovation across. For example, let's say there is a starter motor, reliability or whatever that is. Get familiarized with the industry, know their issues, and when you talk with them, when you pitch for a project, when you research, try to contextualize it heavily. I think that a code, more than industry, computer science, in the computer science area, obviously, you need to go find the blogs. You need to watch YouTube videos. You need to identify who are the top researchers. Okay, they are putting out everything free. Everything is free products if it is possible. If it is the small products, buy them, open them up in your shop, in the workshop, right, and get familiarized with them. It's in engineering journals, for example. There are research articles published in these areas. For example, they'll say, improving.
The next question, the fourth one, is the critical one, which every one of us really look forward to, the examination. If it is for the purpose of a degree, we face an examination. If it is for the purpose of grant of a patent, also we face an examination. And the examinations are conducted by the experts in the field, and experts must feel that we have contributed to original and significant contributions have been made to the knowledge and also to the practice part of it. If the contribution is original and new, naturally, and is significant in the sense that significance is based on its use later, either in theory or in practice or both. So if we are aware of what is that original significant contribution we have made, we would have hit upon two things. One is for the award of degree, naturally, and also any practical things coming out of it in terms of a intellectual property, such as the one that I promised at the beginning of this 5-day program. I said I will illustrate for you how certain things can lead to an intellectual property. I hope you remember what we did. I'm not saying that is the only exercise we can do, but I'm trying to bring out one important factor, the time factor. We had, we could make that product in a matter of a few hours, which is of use to my students straight away right now in this pandemic situation. My students need not go anywhere out to a binding book stall and then ask, but they can instead do it on their own at their own place. So that is what it takes for innovation, and all of us are capable of that. I am very hopeful we can definitely do it. Now there is one question which most people will have. That question is
aspects required for industry, and while you are doing that job, help the academic line to know and generate the patent requirements for that actually. So there the idea of generating or understanding where the patent potential for patent is available, we should be able to identify, and that's what I think the purpose of this FDP was. And I think partly we have definitely met with that objective of sensitizing the academic personnel with the requirement of a patent and the copyright requirements with reference to the work which these people are doing in isolation. Presently, either we are doing our PhD work or otherwise we are working in isolation with reference to patentee and patent and the copyright activities or intellectual property rights. So these aspects have been sensitized. I think the number of people who have attended this FDP also is quite a large number, coming to about 60. And definitely, I'm sure the message has gone across with that academic line that there is a need, along with the connectivity with industry for research, and at the same time, sensitizing ourselves with reference to patent and also the copyright activities. And this has helped me a lot actually. In fact, it is a good information for me too. And at the same time, what little knowledge I had earlier with patent and other aspects, I think, the problem, the time that is likely to take for the activity to be completed for taking over, for accepting this patent from the different countries or international patent. So this is going to take time looking at. My feeling is, let us all look at the basic requirements. Presently, we have actually sensitized, but let us look at how the academic people will be able to.
Definition should be taken in a considerable time. What I mean to say is, don't rush to define problems. What we generally observe is, People just refer some 5 to 10 journal papers and come out with a problem, 11th journal paper, journal problem definition, which will be nothing but a hybrid combination of all these. And that is not a problem definition for us. So what we need to do here is, you guys have to actually move towards industry. For instance, suppose I say materials. I'll give you an example. If you are say looking into do for a research materials, advanced materials, identify the industries which are in and around your city. Okay, at least identify. You don't have to target R&D organizations like DRDO, ISRO, or public sectors like BHEL. And of course, they entertaining us is a very challenging thing. They may not allow us. You put a time span of around 6 to 8 months time at least to go and talk with them. Simultaneously do then converge towards a problem definition. Such problems, sometimes the industry, though it is a medium scale industry, because you are handling their problem, they may come up with funding. You never know, because tomorrow, if they have some confidence on you, they will come up with some small, at least certain percentage of funding. Otherwise, you can depend on some DST or external agency funding. So that is the second phase. But defining a problem useful to some industry is most important. That is, okay. With this, I would like to thank everyone. Thank you once again, sir. Sasri, sir. Thank you.
Thank you, ma'am, for your rich words and giving your valuable information about researcher. Thank you, ma'am. I think that we all are having some questions in our mind. So we have the solution with us with our expert panel. So I request delegates, if you are having any doubt, you are free to ask.
Thank you. One second. Madam?
Yes, yes, sir. Yes, sir.
No, thank you, Dr. Madhavi Garu. That is, she is the chief coordinator of the research and development and the consultancy cell of the MBS Engineering College.
Over a period of 6 months or 1 year or whatever, involve everybody, and then put a review site, put a timetable, and maybe once a month, twice a month, or whatever program, your seminar or whatever, that try going towards that. I think that sort of a focused effort will really help a lot. That's my suggestion.
Thank you, Mr. Moses. And well, before I close the meeting, we could take some questions. Before that, I thought I myself will tell. In fact, when I was presenting, I think it got cut. So I thought I'll just say to doing research, which is linked to in IPs, and over a period of time, of course, it doesn't happen overnight, but over a period of time, generally the culture of intellectual property and patenting has to improve. It's quite late.
Okay.
So we can close the session.
Okay, sir. Thank you. So now I would welcome the coordinator of FDP and secretary of CSI, Dr. A.V. Krishna Prasad, to propose a vote of thanks.
Very good afternoon to everyone. On behalf of organizing team as coordinator of this FDP, it's my privilege to extend vote of thanks for this FDP on academic research in engineering for industry and patents. My heartfelt thanks to honorable management, Mathurshi Education Society, for encouraging support to and supporting to organize this online FDP. I wish to express my gratitude to our esteemed principal and vice principal for giving the permission and guiding us to organizing this event. I wish to express thanks to CS Hyderabad chapter for partnering and collaborating this organizing this event. I wish to express my special thanks to key persons, Professor Ashwini Kumar Garu, Professor Prasanna Kumar Garu, Dr. Madhavi Garu, Chandrasekhar Dasika from CSI, who planned and guided in organizing this event. Without all their support, it would not have been a reality today and achieved this great success. Special thanks to the convener, Professor Ashwini Kumar Garu, who had given shape and strategy to this particular event in writing the objectives, session plans, and guiding the entire event in behind the screen. Initially, this was planned for 3 days, and later extended to 5 days. Again, we successfully added panel discussion. I also wish to thank Dr. M. Sri Ramadev Madam Garu, who involved in organizing this event. I also wish to thank CS Hyderabad Chapter MC member Mr. Nagaya, who reported the speakers from IP Dome. I also wish to extend special thanks to all speakers from India, Ashmi Kumar Garu, Swapna Madam, Hari Prasad Garu, Girdhar from India, and Moses from UK for sharing their knowledge and enlightening us towards research, innovation, and patenting. Thanks to MBSR Entrepreneurship Development Cell, Innovation Cell, Research and Development Cell, Department Coordinators, Muninder, Murali, Vikram, Devaki, Nagalakshmi, Nikhil Murthy, Smita Sri, student coordinators Sai Gautam, Rohit, Yashaswini, Deepika, and entire organizing team. I sincerely hope the objective